In problem 2, we're going to perform another simple regression. This time we're going to regress total cost, the y variable, on units produced x. If you copy just the stuff inside the table may not be preserved in Excel. So grab the period and the entire table, copy it into Excel, which I've already done. After I copied the data into Excel, I flipped the label rows. Instead of having X and Y in row 2 and units produced and total cost in row 1, I put units produced and total cost in row 2. And you'll see why that is in a second. Now to do the simple regression, you go to Data, Data Analysis, scroll through until you get to Regression, hit OK. You click on this button here to define the y variable. Notice I captured the label of the variable and all the numbers below that. Do the same thing for the x variable. Grab the label and the observations below it. Because I included the labels, I want to click on labels. And then I want the output to appear below the data. So I'm going to choose the output range. I don't know why this is, but when you click on output range, always click on the white area. Ensure the cursor is blinking in the white area, and then click on this button. Otherwise, you mess up the Y range. And then hit OK. First things first, I'm going to get rid of all this stuff over here from the p-value for the f and the confidence intervals for the coefficients. Next, for all non-integer numbers, I'm going to reduce the number of decimal places to a manageable level, maybe to 3 or 4. I'll do 3. Now I can copy numbers from these tables back into Cengage Now. The degrees of freedom for the regression, residual, and total are 1, 4, and 5. So find degrees of freedom, 1, 4, and 5. Next, I'm going to copy the sum of squares due to regression. The next number is sum of squares error. Excel calls it sum of squares residual. So I'm going to go ahead and change this to error so that people don't confuse the SSR, sum of squares due to regression, with sum of squares due to error. So I'm going to copy the sum of squares due to error into Cengage Now. And then I'm going to get the sum of squares total. The mean square due to regression is just the sum of squares due to regression divided by its degrees of freedom. So I can just copy this to here. The mean square due to error is this value divided by 4. And instead of doing that on a calculator, I'm going to copy it from the table here. The F statistic is just the ratio of the MSR and the MSE, and Excel computes that for you as well. The coefficient of the constant is in this cell. You can refer to it as the intercept or the constant. It's standard error, copied into Cengage Now. The t-stat is just the ratio of this number and that number. Again, Excel calculates it for you. Then I get the slope coefficient, the slope of units produced, or the coefficient of units produced. its standard error. The t-stat is just the ratio of these two numbers, which is just over 10. So now we've copied all the values in from Excel, and this is where we got to put our thinking cap on. This is where we have to kind of interpret what Excel does. First, we want to complete the estimated regression line. Y hat is the predicted value of total cost, and it equals the constant value to 2 decimal places plus the slope coefficient of units produced to 2 decimal places times x, which is units produced. So there is our predicted equation. That is our simple regression model. Now, because this is total cost and this is quantity, if I differentiate the linear function with respect to x, that derivative is the slope. So all I got to do is copy in the slope here. So what this marginal cost means is if quantity goes up by 1 unit, say from 0 to 1, total cost goes up by $7.76. If firm output goes from 1 to 2, in other words, it increases by 1 again, total cost goes up by $7.76. So every time output goes up by 1 unit, total costs go up by $7.76. The coefficient of determination, otherwise known as R square, is given in the table right here. The coefficient of determination implies 96.4% of the variation in total cost is explained by the model, which in this case is just units produced. Now to calculate part D, we're going to plug a value in, an output value, into this linear equation, which means we're going to replace the x with 500, multiply 500 by that number, and then add that product to the intercept to get an estimate of total cost. To the intercept, you want to add the product of the slope coefficient and the quantity 500. And we get an estimated cost of $5,739.84. And we're going to copy that into Cengage Now. Check my work, and we should get all the problems correct. And we do.